In this video, we will be discussing character vectors and strings in R. Strings are sequences of characters wrapped with matching pairs of single or double quotes. For instance, we can create a variable xlabel and assign the string time steps. Notice that I'm using double quotes here. I could have also used single quotes, and it does not matter in this particular example, as long as the quotes match. If the string contains a single or double quote within it, then you could wrap the string with the other type of quote to avoid confusing the parser. Alternatively, you could escape quotes using a backslash. R uses C-style escape sequences in strings to represent special characters. If we go to the help page on quotes, we'll actually see a listing of these escape sequences along with a lot more information. As an example, we can add, say, a new line to a string using the \n. So if we wanted to write hello world with hello and world on different lines, we would simply add the \n between the two words hello and world. However, notice in the output that the new line, the \n, still appears. This is because R is simply displaying the content and is not interpreting or formatting the string here. If we wanted to see the formatted text, however, we can use the cat function. This function is similar to the Unix cat function in that it concatenates the representations of all objects passed to it, and then it outputs the result. We now get the formatted string displayed, and we see the new line that was generated using the /n between hello and world. In previous examples, we've used the print function, and you'll notice its output is similar to the raw string of the code block in that it does not interpret or format the string like cat, and there is also a 1 in square brackets off the left side. This 1 in square brackets is actually the index of the first element printed on the line. Remember that R treats scalars and even strings as vectors of length 1. Now, when all the items of a vector that's printed begin on a single line or on the first line, then you only see this square bracket 1, as we've seen in most of our examples. But if we were to print something with elements spanning multiple lines, like say the sequence of integers from 1 to 100, we'll see that the first line begins with the element at index 1, the second line begins with the element at index 19, and the third with 37, and so on. And so we see these square brackets are really telling us the index of the first element that appears on that particular line of output. As usual, I do encourage you to check out the help pages, as these functions can do quite a bit more than we're demonstrating here. Okay, I mentioned that R treats scalars and strings as vectors of length 1. And this is true for strings regardless of the number of characters that they consist of. A character vector in R is not a string. Instead, it is a vector that contains strings. And just like with numeric types, we can use the C function to concatenate strings into a vector, like so. And now we have a vector of length 3 consisting of the strings x, y, and z. It is important to remember the distinction between a character vector and a string, because let's say you wanted to know the number of characters in a string. Not in a character vector, but the actual number of characters in a string. And let's say we create a new variable x, and we assign the string a, b, c, and d. And let's say we wanted the length of the string, or the number of characters in it. If we used the length function, we get 1 and not 4 as one may expect. This is because the length function tells us the number of elements in the passed vector, and R treats scalars and strings as vectors of length 1. Recall in the previous sections we showed this with something like length of a number, like let's say 6 here. And this of course will output 1, since the vector containing 6 only has one element. Now, to find the actual number of characters in a string, we need to use another function, the char function. And this tells us the number of characters in our string x, a, b, c, d, which of course is 4. All right, so we've already seen how to use the C function to concatenate elements like scalars and strings into vectors. But what if we want to concatenate the strings themselves? For that, we actually need to use the paste function. This function will combine all passed strings into a single string. However, note in the output, the paste function here added spaces between our 3 input strings x, y, and z. That is because the default separator for the paste function is a single space. If we wanted to change that, we can certainly do so by explicitly passing a value for the separator, like so. And in this case, we're using sep equals open and close quotes without any characters in between to mean we want the empty string to be used as a separator. Thus, the resulting output x, y, and z are concatenated directly. Now, it turns out the paste function is a bit more interesting than this in that we can pass vectors to this function and it will concatenate them element for element. And it will even use vector recycling, exactly as we saw in the previous section, to ensure that the lengths of the inputs match. For instance, if we give the paste function a vector of length 3 containing a, b, and c, and then a vector of length 6 containing the integers 1 through 6, then we get as output a vector of length 6 containing a1, b2, c3, and then notice here that it's recycling the shorter vector to give us a4, b5, and finally c6. So the combination of the vector recycling and the concatenation can allow us to easily create some very interesting strings. For the rest of this notebook, we're going to leave character strings behind and simply focus on a few aspects of strings. First, when you're working with data or a problem in general, you're going to want to write some information to the screen or maybe a file in which someone's going to expect it to read. And so you're undoubtedly going to want to format these strings in some way to make reading and understanding that information cleaner and easier. R supports a number of formatting options, one of which is the format function. This function has a ton of options, so I encourage you to check out the help page, as I'm only going to cover a few quick examples here. Let's first start with pi. Pi is a built-in constant in R. There are actually several constants like this in R, and if you type help pi in the console, it'll actually give you a full list of those constants. But let's say we're interested in displaying only maybe the first 7 significant digits of pi. We can use the format function to do this using the digits argument. So if I create a variable f and I assign to that variable the output of format, x, and pass 7 as a digits argument, I can then printf, and you'll see we get only the first 7 significant digits. We could also print this value using scientific notation by passing true to the scientific argument. And similarly to the paste function we saw previously, we can pass the vectors to the format function and apply various formatting, like, say, justification. So for example, if I pass a vector containing the integers 123, 23, and 6789, along with the justify argument with the value right as a string, when I print this, you'll note that in the output here, all the strings have been left padded with spaces to perform the requested right justification. Moreover, notice that all the strings have the same number of characters. The format function actually used the number of characters from the longest of the input strings to determine the amount of padding to use in all the other strings. This is actually quite a nice feature if you're going to output, say, columns of data, and you want all the values to line up appropriately. So we could do a myriad of formatting examples, but I'm going to leave it to you to check out this function and sort of explore and play with those options on your own. Now, to wrap up this notebook, I would like to show you a few transformation functions that you can also use with your strings. First, we can change all the characters in a string to either upper or lowercase using the toUpper and toLower function. We simply pass the string, and the return value will have the requested case. So if we enter toUpper and pass it the string ABCD with mixed case, when we run this code block, we'll see that we get all capitals in the output. Likewise, if I pass the same string ABCD with mixed case to the function toLower, the output will be ABCD all in lowercase. R also provides the substring function for extracting subsets of characters from strings. For this, we simply pass a string and the begin and end indices inclusive for the characters that we wish to extract. So for example, let's say I had the string containing the characters A through G. And we were interested in extracting B, C, and D. We'll pass the starting index or begin index of 2, which refers to the character B, and the end index 4, which refers to the character D. And we see that in the output we get exactly that, B, C, and D. Now there are, of course, many other functions, and I do encourage you to check out the R manual for additional examples.